Alright, the next three videos we're going to do involve graphing the trig functions. This first one we're going to focus just on sine and cosine so we can get the hang of how these work. And then the next video will have all four of the remaining ones. And then the final video will deal with shifting them left and right. Okay, so let's talk about sine first. First of all, when I put these on the x and the y axis, on the x-axis, those are going to be your thetas, okay? And on the y-axis, those are going to be your sine ratios. All right, so let me give you a for instance. If I look at pi over 2, so here's pi over 2 on my unit circle. And you remember that sine is your y value over your radius. Okay, so at pi over 2, so if I put my first theta on there, pi over 2, and I look at 0, 1, well, the y value is 0. Oh, excuse me, the y value is 1, and the radius is 1. So then I get 1 over 1. So sine pi over 2 is 1. So I put a point here of 1. All right, let's look at the next one. Let's look at pi. All right, if I do the same thing there. Okay, so pi as my theta. Then the y value is 0, and the radius is 1. So sine of pi is 0. All right, and if I keep doing that around the circle, okay, so 3 pi over 2. So if I do that at 3 pi over 2, I'm going to get negative 1. And if I go all the way around the circle, I get 2 pi, I'm back at 0 again. Okay, and then since 2 pi and 0 are the same measurement, I should have another point here over at 0, 0. And if I continued along this pattern, I kept going round and round the circle, I would get all the same values. So even though I'm graphing, okay, so that kind of highlighted red there, that's one full period of sine. So when I say, what's the period, in other words, how long does it take for sine to repeat itself, the period is 2 pi. And that kind of makes sense because every time you go around the circle, all the values start repeating themselves. So the red part here, that's kind of the basic shape of sine. And if you look at the next word down, I'm saying amplitude 1. Well, amplitude is from the middle of the graph. So let me kind of draw that in. Here's the middle of the graph to the highest or lowest point. So in this case, it would be 1. And then the zeros, that's like any zero we've ever talked about, so the x-intercepts, 0, pi, and 2 pi. And sine is an odd function. So if you look at the blue and the red all together, you should be able to see that it has origin symmetry. So therefore it's odd. Now let's do the same thing with cosine. So keep in mind that cosine is your x value over your radius. So if I go around my circle, let's start with 0 radians. At 0 radians, cosine is 1. So I'm starting up here at 1. And then if I go to pi over 2, all right, so I'm up here at 90 degrees, pi over 2. X value is 0 over 1 is 0. Okay, now if I continue that way around the circle, let's do all the basic ones. Pi would be negative 1. 3 pi over 2 would be back at 0. And then 2 pi, back up at 1 again. So if you look at cosine, it kind of looks like a U. And it's one full period. And then in blue again, let me go both ways. So cosine, if I kept it going, would keep going that way, and it would keep going the other way as well. All right, so one full period of cosine, though, is 2 pi. So it takes 2 pi until it starts repeating itself. And then that amplitude thing, from the middle of the graph, up or down, 1 unit. And then the zeros, pi over 2 and 3 pi over 2. Okay, now look at the blue and the red together. Can you see that it reflects across the y-axis? So therefore it's an even function. So now let's change a few things about each of these graphs. Okay, so if I look at number 1, all the same transformations we've always talked about still are in place. So when I say 2 plus sine x, that means sine x, and then take it up 2. Okay, so what we're going to do over here, we're going to graph sine kind of the easiest way possible. Lots of ways to graph sine. You can plot every single point each time. But the easiest way possible means we haven't changed the period, so I start out here at 2 pi, and then I cut it in half again. So all these tick marks I need on your x-axis. So quizzes, tests, make sure you show me all those. Don't just swoop in a little sine curve. Okay, so now I've got my x-axis labeled. Now let's think about the amplitude. Amplitude's still 1 because I haven't changed that. All I have to do is move it up 2. So let's go ahead and do the basic points of sine. Here are the basic points of sine from what we just talked about earlier. And it looks like this. All right, now let's move it up 2. So that simply means I'm going to add a couple more ticks onto my y-axis. Each point now is moving up 2. Up 2, up 2. So all these points are moving up 2. So I have my same shape, just up 2. Okay, now let's answer the questions. Amplitude, remember from the middle of your graph, here's the middle of my graph, up or down. So amplitude on this one, still 1. Period, haven't changed it, excuse me, still 2 pi. Okay, now look at the blue graph. I moved it up 2, so it never touches the x-axis anymore. So I'm going to say none for zeros. All right, now let's look at a vertical stretch. So when you have a 3 in front of your whole function, we would say it's 3 times all the y values. Well, in terms of sine and cosine, now we're going to say the amplitude is 3 because it's being stretched vertically by 3. So now the amplitude is going to be 3. So amp equals 3. So when I go to fill in the blanks up here, oops. When I fill in the blanks, the amplitude will be 3. Okay, since it's just x, the period's till 2 pi. So I'm going to start out here at 2 pi again. Cut it in half. Half again. Okay, so this x-axis, you can see, it hasn't changed for us yet. It will change, but just not yet. Okay, now, instead of an amplitude 1, now I'm going to say it's at 3. And down to negative 3. All right, basic shape stays the same. Goes up, then starts traveling down. And then back to 2 pi. So there is a vertical stretch on a sine graph. So when I say what's the amplitude, we say 3. What's the period? It's 2 pi. And the zeros are 0, pi, and 2 pi still. So the only thing that really changed on that one was the amplitude. Okay, let's look at a little more complicated one. Okay, so the one at the top, number 3, would be up 1. And then we have to remember what a negative in front does. A negative in front of the whole function is going to reflect it over the x-axis. Okay, so first let's start with cosine. So you might have to flip back in your notes or just kind of trust me. But remember the cosine graph. Period was 2 pi. I'm going to cut it in half and then half again. Don't mind that red mark. I don't know where that came from. Okay, so there's my basic x-axis, right? Half pi is all the way to 2 pi. Now, amplitude's 1 because I haven't changed it. Looks like that. Okay, now, cosine, instead of looking like sine, it's like a U shape. So when I go like this, and I swoop in my cosine graph, here are my basic points. And then I graph it in, and it should take this U shape. Okay, so there's cosine x. Now, the negative, let's go ahead and do the negative now. So the negative reflects it over the x-axis. So now, my yellow points here are going to be negative cosine x. Okay, so now it's upside down. So negative cosine x. All right, and then finally, once that's all said and done, now I'm going to take that and move it up 1. So all the yellow is bumping up 1 now to this green. So this green guy here is my final answer. Okay, now let's fill in the blanks. Amplitude, remember, it's still from the middle of the graph, so it's still only 1 for this problem. Periods 2 pi, haven't changed that yet. I will in the next problem, but not yet. And the zeros are only 0 and 2 pi. All right, now let's see how we change the period of a graph. Okay, see this 2x here? Remember that if it affects the x's in parentheses like that, you're actually going to do the opposite of what you think. So we're not going to double the x's, we're going to take half of the x's. And an easy way to remember it is, the new period of any of these graphs is your old period, okay, sine normally has period 2 pi, divided by the coefficient of x. So in this problem, the coefficient of x is a 2. Okay, then I cross my 2's out, the new period is pi. So I can go ahead and put that on my... Okay, now the negative in front is over the x-axis, and the 2 in front stretches the y values. So it changes the amplitude, so I can already go ahead and say the amplitude is going to be 2. Okay, the easiest way to start it when you change the period is to go ahead and get that in place. So the period is pi. I'm going to go ahead and just stick a pi at the end here. And then I'm going to cut that in half. Cut that in half again. And everything's in quarters now. So this guy here should be 3/4. Okay, so when you change the period, that's the easiest way to lay it out on the x-axis. All right, then we remember the 2 in front is the amplitude. Okay, so now I'm going to swoop sine in. Okay, so it starts at 0, travels up first. This is my normal sine shape. Back down to pi. So this green is everything except the reflection. Okay, so now let's take all of that over the x-axis. So now it should look like this. So this blue guy here, final answer. Okay, amplitude is 2 for this problem. And then the zeros are 0, pi over 2, and pi. All right, I want you guys to try number 5 on your own, and please, please, please give it a shot. Please don't come to class with it blank. I know we've done that a lot in the past, but this one I really need you to try so we can get the hang of these. Now let's tackle one that has a little bit of everything going on, and then I'm going to do number 6, and again, I want you guys to try number 7 on your own. Please, please give it a shot. Don't leave it blank, okay? All right, number 6, let's talk about the 1 in front. The 1 in front means up. All right, that's not too bad. The negative in front of the cosine means over the x-axis. The 0.5 is your amplitude. And then here's kind of the weird part, that 1/3 x. Okay, so let's go over the period thing again. Period is your original period 2 pi divided by the coefficient of x. So for this problem, when I do a little flip and multiply, I get a period of 6 pi, so it's stretching it out. Okay, so if I put that up in the blank here, so it's ready to go for later, 6 pi. And then the amplitude would just be 0.5. And the zeros we'll take a look at in a minute here. All right, let's give this a shot. So I'm going to start, there we go. I'm going to start with the period. So if it's 6 pi, I'm just going to put a 6 pi way out here. Okay, and I cut that in half, I get 3 pi. Cut that in half again, I get 3/2 of a pi. Okay, now everything's symmetrical. So this guy would be 3/2, 6/2, 12/2. So this one in between has to be 9/2. Okay, so there's the period all taken care of. Amplitude, you can just put 0.5 or a half on the y-axis. You don't have to do anything special there. All right, and then I'm going to go ahead and draw in upside down cosine because of the x-axis reflection. So instead of being that normal U shape, it's going to be upside down. It's going to start down here, travel up, then back down. Okay, so here's everything except the up 1. All right, now let's bump everything up 1. So if I do that, I'm going to need a couple more points on here. 1.5. Okay, so I'll move each point up 1. Each point up 1. Up 1. Up 1. Up 1. Okay, so here's my final graph in green, which means there are no zeros. Okay, so again, please try number 7 on your own. Do not leave it blank so that we'll be ready to roll in class.